Okay, thank you so much. Appreciate it. So good evening, everyone. My name is Rachel Aronson. I'm with Triangle Associates, and I'm tonight's meeting facilitator, assisting the EPA with this webinar for the members of the Duwamish Roundtable. Thank you all for joining tonight. Tonight's webinar is the third in our webinar series. And if you haven't had the chance to see or experience the previous webinars, they're all on the Duwamish Roundtable website. Tonight's presentation is provided so that members of the Roundtable have a common understanding of the site. And for more information about the site itself, you can refer to the record of decision, and we can point you in the direction of all kinds of details as you to help you answer any questions. We'll be doing a presentation tonight until about 7, and there'll be time for Q&A throughout. At 7, we'll adjourn and you can get to the ends of your evenings, get back to families, and depart if you want to, or you can stay on the line and we always do a debrief of the webinar. So if you have any feedback for the facilitation team or for EPA that will help us improve the meetings and webinars we put together in the future, please stay on and let us know. And let me just do a check-in with our language lines here. How are things going on the Spanish line, Carla? Good? Okay, great. Fung, how are things going on the Vietnamese line? Good? Okay. James?
I hear the music. I don't think anybody logged into the Khmer line.
Okay.
But I see some of the community member here on the English line.
Okay. Well, if folks would prefer to be on the Khmer line, I just pasted that number in the chat. So that's there for you. If you would like to have James's wonderful translation as we go through. We will get going in a minute here. I just want to acknowledge that it's been a weird day. There's been some violence and conflict in our nation's capital. And although we're physically far away from it here in Seattle, it's been a hard day for a lot of people. So I just want to thank you all for being here, for caring about your community, and being part of the work to invest in our community's future, the future of this river, and the sort of thought and energy that you've all put into this super fun process. It brings me hope to see you all come together in a time of great division in our country. So thank you for being here. I appreciate you. Okay, Ellie, I'm going to hand things over to you. And Kay, I think now would be a great time to put up the slides. Thank you.
All right then. Hello everyone, and welcome back for the third webinar about the Lower Duwamish Waterway cleanup decision. Rachel stole my intro, but I'm Ellie Hale, the EPA project manager for the Lower Duwamish Waterway Superfund site. And I want to thank the Roundtable Steering Committee who helped review the slides, and the interpreters and Triangle. And of course, I appreciate you for coming back to learn more. It may be rough if you haven't seen the last 2 webinars. So anyway, we'll be helped today by Triangle Associates, and Mishu has some housekeeping to talk about. Mishu, please introduce yourself and explain how we will do this webinar. Next slide, please.
Slide. Thanks, Ellie. Hi, everyone. Mishu Famwickel with Triangle Associates here. Hopefully these ground rules aren't new and you've been tuning in with us, so thank you for doing that over the last few webinars. Just as a reminder, you can enter your questions into the chat and we will get to them at the end of every section. So just sit tight with those. If it's helpful if you include the slide number that your question is related to so that we can flip back to them easily. And as a reminder, this meeting is being recorded, so it'll the recording will go up to the Roundtable website, as well as the summary once it's translated. And as Rachel mentioned, there's a transcription tool at the bottom of your screen to help some participants. So hopefully that's not too distracting. And it's not 100% accurate, as you might have noticed. So please bear with that as well. Thanks for your patience as we have simultaneous interpretation going on. So we may take some pauses throughout the presentation. And if you have any technology issues, you can text me at this number that I'll put in the chat. Okay, I think that was all.
Okay, next slide. I'm back. First, another reminder. The reason we are here today is that you are on the Lower Duwamish Waterway Roundtable. The three-part webinar explains our cleanup plan for the Duwamish, the record of decisions. Understanding the cleanup plan will help you participate in the roundtable as we go through design and construction. The roundtable was created to help EPA reduce impacts of cleanup on the people who live, fish, play, work, and study on and near the Duwamish. If you missed the first two webinars or need a refresher, feel free to watch it online. Mishu may have the links ready to post, but they're certainly on the Roundtable webpage. Next slide. It's been a while since the last webinar, so I'm going to remind you of some of the things we learned. We learned that the cleanup plan, or record of decision, ROD for short, was written in 2014. It summarizes the big study called the Remedial Investigation and Feasibility Study in its chapters 1 through 12. Today, we're focusing on chapter 13. You remember that 5 areas of the waterway were cleaned up before, during, or soon after the study, and these are called early cleanup actions, early action areas. The cleanup plan focuses on in-waterway sediment cleanup, while our partners in the state of Washington Department of Ecology are working to control pollution sources. In webinar 1, we learned that sediment cleanup levels are our goals for levels of pollution or contamination in sediments or mud. What these levels are and where they must be met come from understanding the way people or animals may come in contact with contaminated sediments or seafood, and how clean the sediment must be to protect animals in the mud and all the way up the food chain, and people who may contact sediment while fishing, clamming, or playing on the beach. Some of the cleanup levels are set to background levels seen in other parts of Puget Sound, because that's the best we can do, even if the goals for risk would be met at pollution levels lower than background. Section 8 of the cleanup plan is where you find the cleanup levels. It also has goals for seafood called target tissue levels. The next one, what is a remedial action level? Well, in webinar 2, we learned about remedial action levels, and they are presented in section 13 of the cleanup plan. Remedial action levels are different from cleanup levels. They determine where active cleanup is required. These levels used for the remedial action levels are often higher than cleanup levels, but not always. The goal is to reduce risks from pollution through active cleanup, and then to allow natural processes to bring overall pollution levels across the waterway down further over time to meet the cleanup levels if possible. Like the cleanup levels, the remedial action levels apply to different areas and depths. So we'll go into more detail on those. We also learned that cleaner sediment is coming every day, every minute from the Green River. And in some places, that sediment comes in, lands on the bottom, and builds up, helping to make the sediments cleaner near the surface, where most of the animals live and where people contact mud. This process of reducing pollution levels naturally is called natural recovery. In parts of the waterway, this process happens faster because more new sediment comes and stays. In other areas, currents might move the sediment away, maybe even not leaving something behind, but scraping off what's there. This is important, and the cleanup plan factors in natural recovery processes. Finally, we've learned what kinds of sediment the cleanup, what kinds of sediment cleanup the cleanup plan requires. This is also in Chapter 13 of the ROD. Next slide. We showed this slide last time, and it's the 4 cleanup methods described in the ROD. Monitored natural recovery is not an active cleanup, except that we use monitoring, the activity of sampling and testing. But monitored natural recovery is simply letting the natural recovery process happen. Green River sediment will naturally settle on top of contaminated sediments in most areas. And in the cleanup plan, we show that about half the waterway is already clean enough and that active cleanup isn't necessary. It's below remedial action level. But these areas do need to be monitored, sampled over a 10-year period or longer to make sure sediments are continuing to get even cleaner. And then there are the 3 active cleanup methods. They apply in areas where contamination is above remedial action levels. Enhanced natural recovery is adding 6 to 9 inches of clean sandy material over contaminated sediment, like the Green River does all the time, but all at once, and we do it. We can use this in areas where natural recovery processes are happening, but not fast enough. Adding this material enhances, makes better, speeds up the recovery process. Enhanced natural recovery, we call it ENR. So if I say that, that's what it means. It's not allowed in the navigation channel where there's built up sediments or where Green River sediments are not likely to stay. We call those areas recovery category 1 areas. Dredging is another technology. It removes contaminated sediments, it excavates it, and in some areas, we might find that the contamination to be removed is not very deep in the mud. So after dredging down a few feet, the rest of the mud is clean. But in some areas, there may be contaminated sediment more than 4 or 5 feet deep. And if so, the cleanup plan says that the dredging can stop when there's enough room for a cap. What is a cap? That's the next one. Capping is containing contaminated sediment under a thick layer of clean sediment. The layer is 3 to 4 feet thick as a rule, and it's much thicker than enhanced natural recovery. Capping is only for areas where contamination levels are higher and the water level, the water depth is enough that adding 3 to 4 feet to the bottom won't be a problem for water depth for boats or animals animal habitat. There are a few areas where capping alone will be used, perhaps, but in some areas, we'll use partial dredging to make room for a cap. Dredging down and cap it. Next slide, please. So that's what you already knew from earlier slideshows, and there's more that you know, but it's a lot. There's also, though, a lot more in the cleanup plan to understand, like how do you know when to use enhanced natural recovery and when capping or dredging and capping is required. And there are lots of factors that affect this decision. Today, we'll go over them. There's something called the upper limits for enhanced natural recovery. Where do they apply? What do they mean? There's remedial action levels, including for benthic organisms. And I want to talk about biological testing and how that fits in. And along the way, we'll do some examples of how to compare sample results to Table 28, remedial action levels, and upper limit enhanced natural recovery limits. And we'll also do a practice with some of the flow charts that are in the ROD. We'll touch on elements of the cleanup plan that are not just technical, and at the end, we'll look at some examples of a completed design. This isn't part of the cleanup plan, it's bonus information, lucky you. Next slide. So the selected remedy is what we call Chapter 13 of the ROD. And it's called the selected remedy because after considering public comments, EPA chooses or selects how to fix, remedy, or remediate the problem. This part of the cleanup plan explains exactly what actions EPA has decided are necessary to meet the long-term goals to protect human health and the environment. Here are a few key elements. There's narrative description of the cleanup plan in words with tables and flow charts that provide action levels and explain what cleanup method will be used. That's the focus of most of today's slides. It does consider the whole waterway, including areas that have already been cleaned up, including the navigation channel and early action areas and habitat restoration areas. Everything needs to fit together with the active uses of the waterway and the function of the river. It also notes that waterway activities can be restricted in some areas to protect caps, where caps are used. If that's not possible, if we can't protect the cap, it requires dredging or other action. It provides an estimate of the cleanup costs and timing. And for your information, the ROD estimates that the cleanup would cost $342 million. It also estimated that construction work would take 7 years. That sounds like a lot, and it may not happen in a continuous 7 years. We hope it does. But note that construction is only possible about 6 months of the year. Other parts of the year, construction is prohibited to protect fish at sensitive life stages. Next slide. Again, the ROD isn't just what cleanup has to happen where, but also a little bit about how. Because we still want to meet the cleanup levels, the long-term goals after active cleanup. So the plan calls for monitoring to track the progress of natural recovery across the waterway, and especially in the natural recovery areas, for at least 10 years after active cleanup, to show the condition of the sediment and changes in the seafood contamination levels. The ROD also recognizes environmental justice concerns. You may have heard this term. The Lower Duwamish Waterway Superfund site affects communities that are already impacted by air pollution and noise pollution and other conditions. People who fish in the Duwamish include members of communities that have economic or language or other barriers. We want to ensure that communities understand and have meaningful input in the cleanup process. That's why we created the roundtable. It's also why we are working with community health advocates, on institutional controls. For seafood, we are committed to appropriate and effective ways to give people options for eating safer seafood. Finally, the cleanup plan calls for green remediation methods. And what does that mean? Next slide. Cleanup is important, but it has impacts we can't avoid sometimes. So we want to try and use methods that are as efficient and sustainable as possible, and that protect the air and water and minimize contributions to climate change. For example, we expect to try and use low sulfur fuel and equipment that does less pollution. We want to use trains, not trucks, to carry material that's been removed to disposal sites like landfills. We want to look for nearby sources of material and equipment. So next slide. This is a little review because we saw this picture before. I just wanted to remind you that based on the big study of the site, the RIFS, and that there are individual samples of sediments. And it shows, this figure shows that there are different contaminants at different concentrations or levels in different locations. But you can't clean up a spot. So how do you define areas that need active cleanup? What areas should we leave alone so that after active cleanup, natural recovery will finish the job and help us meet the cleanup levels for the whole site? The remedial action levels help us focus active cleanup areas. Next slide. This figure is figure 18 from the record of decision, and it was developed by comparing sediment concentrations from that big study to action levels that were selected in the ROD. As I noted before, you'll see that about half of the waterway in light blue is not expected to require active cleanup. These areas are below remedial action levels, and we will monitor them. In other areas, dredging, enhanced natural recovery, and tapping, these areas are approximate. The samples or individual data used to make figure 18 are in some cases over 10 years old. And this is an active waterway. Conditions have probably changed in some areas thanks to the cleanups that were completed, shown in gray, the natural recovery process, and ongoing control of pollution sources. This much detail was just fine for estimating costs and making a cleanup decision. But for design, we need exact areas to ensure that we can hire contractors to do the work we need to do exactly right. So during design, we collect more samples, compare the sample results or data to the remedial action levels, and consider other information. So if I sound like a broken record, sometimes repetition helps us remember. The next section is the hardest and longest part. Stay with me. It will all make sense at the end. Next slide. Last time we looked at this table, table 28 of the record of decision. This is actually just half of table 28. We touched on it in webinar 2, and it's really complicated. But if you understand it, it tells a clear story. On the top row, see the top green arrow. This says intertidal sediments. The other half is for subtidal sediments. Remember that intertidal sediments are underwater at high tide, but above water when the tide is out. Subtidal is always underwater. We'll focus for now on the intertidal part of the table. As we learned before, it shows the remedial action levels. We see the white rows that have the yellow boxes that say RAL or RAL. Yes, we call them RAL. For each of the contaminants of concern, next to the arrow that says, is active cleanup necessary? So you know by now that if you're above the RAL, active cleanup is necessary. The upper 4 rows in white are the RALs for contaminants of concern for human health. And the lower 1 row is for benthic organisms and protection of them. I'll talk more about them in a minute. But remember, the RALs in the rows tell us what level of contaminant requires active cleanup. And the columns tell us in what areas or mud depths. So let's go to the columns. See, the second green arrow is natural recovery likely. The 2 columns under the red oval are for areas where natural recovery is slow or insufficient because sediments from the Green River won't stay, and maybe there will be erosion. These are recovery category 1 areas. So when I say no in red, natural recovery processes are not likely to help here. The next 2 columns under the green oval, where am I? Yes, are for areas where sediments from Green River will settle and stay. We're pretty confident of that. And so the numbers can be a little bit less strict. There are 2 columns under each of those ovals because in intertidal areas, we have a RAL for the top 10 centimeters, and we have a RAL for the top 45 centimeters. 10 centimeters is about 4 inches, and 45 centimeters is about 1.5 feet. When you sample in an intertidal area, you need to collect a sample of the right depth, and you need to know if you are in recovery category 1, the red oval, or not, the green oval. So let's look at an example. Next slide. Let's say you go out and you collect a jar of mud from the beach. It's intertidal, and you take it to the lab, and the lab gives you this table, and the table says there are 20 parts per whatever, we'll say parts per billion, but that's not, I'm ignoring units here. 20 parts per something, ppb. So you take that 20 and you look at table 28, and the remedial action level is 12 in this case, because you know how deep your sample is, where you collected it. 20 is greater than 12. Action is needed. This part was easy. You already knew that. And you then can mark that location as part of the possible cleanup area. Next slide. Looking at this table once more, PCBs, remedial action level, 12. Check. In this case, it doesn't make a difference if you're under the red oval or the green oval. And it mostly doesn't make a difference if you're looking at 10 centimeters or 45 centimeters. But you will notice 65 is in the last column, and that's because some natural recovery process is expected. So we won't have to clean up as quickly because it will be covered up by cleaner sediments soon. Next slide, please. Which method are we going to use? This is the other part of table 28 that I had to study about myself. There's something called the upper limit for enhanced natural recovery. This is not review. This tells us when we can or can't use enhanced natural recovery. Enhanced natural recovery has some benefits. It reduces contamination levels in sediments. It uses less clean sand than a cap, and it has less impact on the environment. It doesn't change the depth so much. It's also less expensive. But when should it make sense? Well, enhanced recovery, 6 to 9 inches of sand to make healthier sediment. But for areas where Green River sediments won't stay, and there might be erosion, the natural recovery process isn't helping cover the sediments. And deeper sediments may be exposed. So the ROD says no ENR, no enhanced natural recovery. You must do capping or dredging in those areas. For areas where Green River sediment is expected to stay and slowly make the area cleaner, the ROD allows enhanced natural recovery to speed it up, as long as the level of contamination is not too high. What's too high? The ROD sets an upper limit, your enhanced natural recovery upper limit. If the level of contamination in the mud is more than the ROW, but less than that upper limit, enhanced natural recovery is the remedy. That limit is 3 times the ROW, 3 times the remedial action level for the 0 to 10 centimeter, and 1.5 times the ROW for the top 45 centimeters. That's shown on table 28. Next slide, please. Let's take a look. Okay, so the UL or ENR is our special short way of saying upper limit for enhanced natural recovery. And the shaded rows show the ENR upper limit for each contaminant, and like the ROW for each location or location type. You see that if natural recovery is not likely, you're in a natural recovery area 1, then no, you do not get to have an ENR upper limit. The table shows a hyphen instead of a number. In the yellow ovals, there are numbers 36 and 97. That is 3 times the ROW of 12 and 1.5 times the ROW of 65. This is because ENR, enhanced natural recovery, is allowed up to those numbers. Okay, let's go take a sample. So once again, you go out, you're on a beach. This time you know you're in an area likely to recover. You collect your sample. Again, you got 20 as your amount of PCBs, and you compare it to the table. You already are above the remedial action level, but are you above the ENR UL upper limit of 36? No, you're lower than that. 20 is less than or lower than 36. So you can use ENR in this area. And so you can mark your map and make a group of areas that get ENR. ENR, enhanced natural recovery, sorry. Mark your map and let's take another sample. Next slide. Okay, so once again, we're sampling, but this time we're in an area not likely to recover. We have the same results, but when we go to the table, there's a hyphen where it says ENR UL. So in this case, it's got to be dredging or capping, or partial dredging and then capping, not ENR. Next slide, please. So one last one. You're collecting a sample in an area likely to recover. Your result this time is much higher. It's 42. Clearly, you already know it's above the remedial action level of 12. Is it above the enhanced natural recovery upper limit? 42 is greater than 36. So yes, it is. You have to dredge or cap, even though we know Green River sediments will help us over time. So let's say we take a sample and let's see, I think we're already there. Yes, I'm getting distracted. That's so in this case, it's because not because it's in a natural recovery category 1 area, but because the level is too high, and so we think action is needed. Next slide. Back to table 28. You're going to be so sick of this table. I know I am. But you get to know how to read it. And this shows you, again, the upper limits and how you had sampled results that were higher than that. Next slide. I focus a lot on the upper part, the human health contaminants of concern and their remedial action levels. But we also want to protect the organisms that live in the mud, the benthic organisms. They are key parts of the food web. The contaminants of concern for benthic protection have remedial action levels on the bottom row of Table 28, and they have upper limits for enhanced natural recovery. But wait, you say, there's only one row, and what is benthic SCO? Well, there are 39 chemicals of concern in addition to PCBs and arsenic that are of concern for benthic organisms. And each chemical has a RAL, a remedial action level for benthic protection. The benthic protection RALs are individually listed in a separate table of the ROD, Table 27. Table 28, our RAL table, refers to the term benthic SCO in the green oval to refer to benthic RALs. Let's talk about the SCO. Yeah, pause for a second here. SCO stands for, stands for sediment cleanup objectives, and it's not a term that we invented. It's one of two regulatory levels used in Washington state to protect benthic health. To develop these levels to protect benthic health, scientists used data from many locations in Puget Sound. For each location, they had data for chemicals in sediment, the population or community of organisms living in the mud, and information about the toxic effects of the sediment in laboratory tests. Based on these data, we understand what chemicals are toxic to the organisms in many locations. The benthic SCO is the level of a chemical that is associated with no toxic effects. There is another level, and that's not used in the ROD, but it has minor effects. Setting chemical levels associated with benthic health allows us to use chemical data when we want to. And that's why we have these numbers in Table 28. Next slide. If the contaminant is above the benthic SCO, we expect that the sediment is toxic to benthic organisms based on chemistry. But maybe it's not. The state law and the ROD allows people to do the same kind of biological tests to see if the anticipated or expected harmful effects are happening. If the harmful biological effects are not happening, cleanup would just disturb healthy benthic organisms. Their health is what's really important, not a chemical number. So if the sediments pass the biological test, that location does not require cleanup for benthic protection. So EPA uses the chemical SCO as a RAL in Table 28 for recovery Category 1 areas. And we allow biological testing to replace or override the chemical results. Of course, you can't get out of jail free. There's no test out if there's contamination above human health RAL. Next slide, please. What are these biological tests that make sense to use to override the chemistry? Well, laboratories take mud samples and expose certain organisms that live in mud, like worms, baby oysters, amphipods, to contaminated mud samples. These are then, these measure things like how many organisms survived, or how much they grew, or if they grew normally. These tests are specified by state law. They also use clean mud samples to make sure that the tests are showing what the chemicals are causing, not something else, like how big the particles of mud are. I'm explaining this because during the design of the cleanup, the designers might want to try biological testing in some areas, particularly if the levels of contamination are close to the SCO, or if it could really reduce the amount of cleanup if the sediments are shown not to be toxic. We're almost done with table 28, but not quite. Next slide. I don't want to rest on this one. This is the other half of table 28 for the subtitle areas. And you'll notice that it has 5 columns of numbers, and the last column is for the navigation channel areas where the Duwamish is filling up from too much Green River sediment in the bottom of the channel. The channel has to be kept to a certain mud depth for safety. They want enough water for boats to pass freely. So in the yellow box, the RALs apply to sediments that are built up above the depth that the Corps of Engineers requires for safe navigation. Otherwise, like the intertidal part of this table, the subtitle part shows action levels for 2 mud depths, the top 10 centimeters and the top 60 centimeters. This time it's 2 feet, not 1.5 feet. And there are the same 2 recovery categories. There are upper limits for enhanced natural recovery in the gray rows as well, but only where natural recovery processes are happening. See the hyphens in the columns under recovery category 1. ENR is not allowed in areas where natural recovery processes are not licensed. Hyphens under the red heading. It's also not allowed where sediments have built up in the channel, as they must be dredged. So they are dredged for navigation safety. So see the yellow box. There are hyphens there too. All right, let's rest our brains and take a break from table 28. It's time for questions. Anybody have questions they want to ask?
Thank you, Ellie. That was a big lift through the table 28. If folks have questions, you can type them in the chat. You can raise your hands in the Zoom space, or you can unmute yourself and we can check in. Any questions for Ellie on this section of her presentation? If there are broader questions, I may ask to hold until the end. Samantha, I see you've got a question.
Hi. Yeah, I was wondering about the biological tests on the benthic organisms. So what type of, like, is there a standard for how many replicates you have to use and where you need to take the sediment samples from? Because I was just wondering if, like, I don't know, if you take one sediment sample and it doesn't happen to kill the organisms, then it might be said to be okay, but it's actually like quite patchy. I'm not sure.
Right. And I think that when they sample, they measure the chemistry at the same time. So you have an association with the chemistry. And the Puget Sound Estuary Program guidelines make it very clear how these tests are done. So I think that while you may not have to do multiple replicates for one location, I'm not completely sure about that. I would want to refer you to the guidelines. There's a term called SCUM2, which is the Sediment Cleanup User's Manual that the Department of Ecology uses to support the sediment management standards. And I think that might be specified in that.
So Ellie, to sum that up for our translators, the answer to that question is that the Department of Ecology manages the requirements for the sampling.
Correct.
Okay, thank you. I'm going to check in with our language lines to see if there's any questions on the language lines. I'll start with Spanish since I see Carla's face first in my video screen. Carla, are there any questions from the Spanish line?
¿Hay alguien en la línea en español? ¿Alguien está en la línea en español? ¿Alguien tiene preguntas? I don't see, I don't hear anyone
Okay,
in the line, so I guess no questions.
okay, thank you, Carla. James, are there any questions on the Khmer line?
I do not have anybody on the line.
Fung, are there any questions on the Vietnamese line?
Capturing a question.
Okay, does that mean,
Ellie,
is there a question?
Yes, we're capturing a question from the Vietnamese line. I see
Oh,
your
okay.
hand, James. Let me just get this one question from Fung. Thank you.
Okay, cảm ơn cô Tuyết. Hi, can you hear me?
Yes.
Okay, great. Yes, Tuyết has a question regarding the level of contamination. So she heard that if the level is 12 or 18, then does that mean it's contaminated or polluted and it's not safe for human health, such as fishing? For example, if you at a certain spot in the Duwamish River, is it correct? Is the cutoff 12 centimeter? Is it centimeter? She's not sure what is the measurement, but she heard 12 or 18 is the level, is that level is a cutoff?
It's the number that requires active cleanup in some parts of the waterway where there's PCBs. So it may help if she looks again at the earlier webinars, because some of the cleanup numbers, the cleanup levels, were based on risk, and the risk, health risk, is from being exposed to or contacting contamination, either by eating seafood or by touching mud and doing it for a long time and for quite a lot of, for a lot of time each time. So for example, if you are a person who regularly goes out and collects clams, or you're a person who is out fishing and pulling in a fishing net, there might be mud on the net or mud when you're clamming that gets on your hands, and then it gets into your mouth. So because people touch their faces. So those are, it helps to understand that's why those depths matter. Most of the organisms, the benthic organisms, live near the surface. But I think her question is more about seafood. And so I think for safety, focus on the chemicals in the seafood. That is the biggest source of risk.
Mm-hmm.
I have a question.
Thank you.
This is Rod. I don't know how to raise hand in this thing. Sorry.
Sure. Hold on one second, Rod. I think James had a hand up.
Okay, okay. How do you raise hand, by the way?
Oh, that's a good question. If you click on your own name in the participants, that should let you.
Okay.
But I don't know what kind of device you're on, so it might change for everyone. We'll
I'm on a
address that
computer.
in the chat. Our tech folks can help with that.
Okay.
And I will get to you in a second for your question. James, you had a question?
Just a very general question. And number one, I would like to thank Ellie very much for her very concise explanation of Chapter 13, which is not easy to do. But one thing you did not talk about was the issue of climate change. And we did have a seminar on climate change at the beginning of this administration. And there was a lot of discussion about what that's going to mean for the cleanup. Can you elaborate if that has changed anything at all or nothing at all?
I can say, and this might be a question that we should discuss at the end, but if I can be quick about it first. That seminar was to look at source control and shoreline operations and cleanup to see if people are making the same understanding, do they have the same understanding of climate change? And given that understanding, what are they doing to prepare? So it was not just about the sediment cleanup. And my understanding is that because of a number of factors, the effect on the sediment cleanup is actually not as great as you would expect. So we know that intertidal areas are affected by wave action. And if the band of sediment that is called intertidal changes, we'll have a higher high tide and a higher low tide. Then we need to consider how to protect sediments that are outside the current band. We have to anticipate changes in sea level and possible erosional effects.
Okay, thanks, Ellie, and thank you, James.
Thank you. Sorry, go ahead.
Let's put a pin in climate change for our broader conversation at the end. And I want to make sure we've got time for folks to ask questions about that table 28 section that Ellie just went through, since that was pretty detailed. The gentleman who had a question earlier, your display name is Lay.
Sorry, this is Rod with the Khmer Cha. My question is, since the inception of the projects, has there been maybe a reevaluation to see if the natural recovery process is taking effect faster, so that the project might go shorter or anything like that, or it's just still the same on the same timeline?
That's a question that's a really good one to ask, and it's complicated to answer. Natural recovery, I'm simplifying it. It includes knowing what is in sediment coming from Green River, knowing how much sediment is coming, and that changes from year to year or time to time. And also knowing what it does when it gets into the Lower Duwamish. And there was a lot of work done to model that using computers. The inputs to the model were re-evaluated as part of a study after the ROD. And it did not change. Sometimes you can have a change in a number that doesn't change the output or the conclusion. So even though we saw maybe lower amounts of pollution in incoming Green River sediments, we didn't see enough change to change the timeline for natural recovery.
Okay, thank you, Ellie. Thank you, Rod, for your question. I see Paulina's got a hand up. So we'll take Paulina's question, and then we'll take a pause in questions, and we'll move on to the next chunk of Ellie's presentation, but we'll have time for more questions later. Paulina,
I think I'm going to put my hand down because James asked the question that I was going to ask about climate change, but it was more related to the testing, like if whether we anticipate because of climate change, the testing that has that has already happened, if we are anticipating some changes on the numbers that we already have. But I think that I heard we're going to discuss this a little later. Thank you, Ellie, for the presentation.
Sure, thank you. Okay, so now you know enough about table 28, but we're not done with the ROD. It's almost what you need, but the cleanup plan considers some other things, and there are flow charts to make it clear how to factor those in. Some people love flow charts, and some people hate them, but let's look at one. Next slide. This is a simple flow chart where you have a problem, the lamp doesn't work, and you ask yes or no questions, and depending on the answer, you have an action. So if your lamp isn't plugged in, you should plug it in. Is your bulb burned out? If the answer is yes, you can replace the bulb and everything will be okay, maybe. But if that's not the answer, if the answer is no, and you keep going down that path, you end up with, uh-oh, you have to repair the lamp. Sediment is even more complicated. And sometimes a flow chart is hard to read, but it does make it very clear. So we need to think, what are the questions we would ask to determine when we use natural recovery, enhanced natural recovery, that is, when we'll use dredging, when capping, or a combination of dredging and capping. So the ROD has figure 19 and figure 20 for intertidal and subtidal. These are both flow charts, and figure 20 for subtidal was corrected after the ROD. So we'll go into that a little more. We're going to look at the subtidal flow charts. Next slide. So the first box is, are you or aren't you above a RAL? So I'm skipping that. We are above a RAL, let's say. And the first question in the flow chart is, are there structural or access limitations? Like, can you actually do the cleanup without damaging a structure, or can you get the equipment into a tight space under a pier, for example? And if there are such limitations or problems, then you have to make a special answer, which we'll get to, but it's basically a site-specific, a one-by-one decision. But if you don't have structures, and there's parts of the waterway that don't, then you go to the next question. What recovery category is it in? Is it in recovery category area 1? And if the answer is yes, as you recall, then we know it's not going to be ENR. So there's that, we know it's not ENR. And if the answer is yes, no, it's not in recovery category 1, that means natural recovery is likely. And then we go to the next box, which says contaminants. Well, you know what, the script is in my way. Contaminants are the contaminants greater than the ENR upper limit? So we know what that is. It's in table 28. And if the answer is no, it's not greater, it's not more than the ENR upper limit. So in that case, we can go to the next slide. Oh, and sorry, can you go back, okay? If the contaminant levels are greater than the ENR upper limit, then the answer is yes, we go to the left. It's too dirty for ENR. Okay, now down. Now next page. Okay, so where we were is the right side. Is there room for an ENR? Now we can do ENR maybe, but is there room for ENR? And if the answer is yes, there's room, then let's do it. Let's do ENR, enhanced natural recovery. If the answer is no, there's not room, which sometimes happens, then you have to look at dredging. And then the question is, if you dredge, and you dredge down enough to make room for a cap, will you be finished? If you get all the contamination out, will you be finished? And if the answer is yes, then let's just dredge, right? So actually, in this case, I'm sorry, is the answer no. Will more than a foot of sediment be above remedial action levels if you dredge deep enough to place a cap? No. So if there's not a lot more sediment going down, down, down in the mud, then just dredge out what you need to dredge. If there is a lot of sediment going down into the mud and you can dredge you can keep dredging to get a cap, make room for cap, then you dredge and cap. So we went back to continuing from the other slide on the left side, contaminants, where it says ENR is not allowed. So if ENR is not allowed, you ask, is there room for a cap? So we are in recovery category 1 areas, or you have concentrations higher than the ENR upper limit. Is there room for a cap? If the answer is yes, just use a cap. That's enough. We're okay with that. But again, if the answer is no, then you ask, how deep do you dredge? Do you dredge it deep enough to get rid of everything, or do you dredge it deep enough to make a cap? That was complicated. Next slide. So I mentioned structures and access limitations, and that is a question that if you have some problems like that, then you have to make, the designer, the engineers, have to make a site-specific decision, case-specific decision. But sometimes, because the ROD doesn't say exactly how the situation will be handled, sometimes you can do dredging under a dock using divers, or you can put material over the contamination instead of dredging, or you can remove a structure, and if you need to, you can replace the structure to do the cleanup. Sometimes there are old wood pilings that aren't being used, and sometimes it's easier to just take them out and do cleanup. So next slide. I told you that the other part was the long part, this was the short part. And you now have the ability to understand the flow chart. So the next slides I'm going to cover quickly, but are there questions about the flow chart?
All right, hold on one sec, Ellie. Questions specifically about the flow chart section here. I'm looking at our interpreters.
Okay.
James, any questions about this section? Oh, thanks.
From our end, I still don't have anybody
okay.
in
Thanks.
my line.
Thank you. Thanks for being there just in case. Fung, any questions from your group at this time?
Not at the moment.
Thank you. Carla, any questions at this time? No? Okay, all good. All right, Ellie, no questions on this section. Let's keep rolling.
Let's roll. Okay, so that was, you've been through all of the numbers and the tables and the flow charts, and that's really the hardest part to grasp. So the next few slides, I think, will go pretty quickly, and they're mostly about the design process. Not all of this is in the ROD, but I'll talk about what happens after the ROD to get to cleanup. So first, we have to better define the areas that need active cleanup by doing sampling. The picture, figure 18 from the ROD, is less detailed than a designer needs. And like I said, the data were collected at various times, and some data are quite old. Maybe conditions have changed. And you need to compare the results of the data to outline areas for action. So we have done a first phase of sampling in the upper reach. And I think if you're on the roundtable, we talked a little bit about that. The next thing you need to do is get other important information about site conditions for design. And then you, the engineers, will make the design submittal or package. And that involves lots of material, engineering drawings, specifications, and many, many plans. Let's go to the next slide. This is a slide that sort of says what things we might need to know to design the cleanup other than just RALs and upper limit ENRs. If dredging is required in an area, how deep is dredging going to be needed to make sure that after dredging, we meet our remedial action levels? Will dredging 3 or 4 feet remove all the contamination? If there is deeper contamination, remember a cap may be needed after dredging. What conditions do the designers need to consider? Currents from the river might erode in some areas, whatever you put down. Are there sources of groundwater that will push contamination upward through the cap? And what about biological disturbances? What about human disturbances? Is the area close to structures? Is it next to an early action area? So the completed early action needs to match up with the new sediment cleanup in other areas, adjacent areas. What about habitat restoration sites? How do we match up the edges? And what about boats? Is this area in a place where boats are kept for storage, or where navigation is needed, and so there's already some need to have depth of water? So those are some questions. Also, where should we take the dredge sediments? I think we know that there are 2 likely locations, but where do we get the sediments from the dredging onto a barge, and then from the barge, this flat boat, onto land, and from land onto a train? And how do we capture or control pollution in the water that comes out of the muddy mud, right? If you pick up mud, there's always water that comes out. Those are things to consider. And if you're capping, you need to consider things like, what is the slope of the bottom that you're putting a cap on? Is it too steep? How do you protect the cap from being eroded by waves? How might climate change affect that? What is a good source of clean sand and other cap material? And what impacts are there to the community? How can we minimize those? Noise, traffic, lights, smells, all that. Next slide, please. Another thing about capping is that capping may be useful to cover and control contaminated sediments, but we have to protect the cap, not just from erosion by currents, but also from damage by people and their activities. There's something called budding, where barges poke a big post to hold their barge in place, and it pokes down into the bottom. So we'd need to make sure that such activities don't happen where there's a cap. Next slide. We can use signs. Oh, sorry. Okay, can you back up? I'm sorry, I rushed ahead. We can use signs like this one from slip 4, and we can mark maps and let the Coast Guard know that we don't want people to do certain things in certain areas. So there are ways to do that, and it's not perfect, but it does seem to be working in slip 4. But it's a busy industrial waterway. The ROD says that if you can't protect the cap, then dredging may be required. Next slide. Whatever we do, it has to comply with or meet requirements of other environmental laws and laws like worker safety, speed limits. Protection of cultural and historical resources, endangered species, water quality protection, navigation channel requirements. So the design will include plans for meeting all of these requirements. What does a final design look like? I'll show you some examples that were prepared for the design of Terminal 117, where a cleanup was completed by the Port of Seattle in the waterway part. Next slide. This is an early action. This is an example of a design drawing or engineering drawing, and it shows here the depth of excavation on land, the part in the middle, and then outside of that, above that, is the slope into the waterway. And so it shows how deep the dredging had to go in the waterway and what the final slopes had to look like. It also talks about the soil, but we won't have soil excavation for Lower Duwamish Waterway cleanup. Next slide. Specifications are really detailed instructions so that the contractor does the work a particular way. And they're often hundreds of pages long, and they have details about how to measure things, what controls will be required, how workers will be protected, how the contractors will be paid, how the work will be tracked and documented, what kind of communication will happen with the community or with the agencies, and what reports are required, when is work allowed and when isn't it. It's a lot, and there's just one example here pulled forward as an example. Next. Here's another example. This is a design drawing that shows a side view or a cross section where we imagine what it would be like if we drew a slice in the land and could see the sides. So this is the slope, and it shows where riprap or coarse material was placed on top of the slope to protect it at T117, now called the Duwamish People's Park and Shoreline Habitat. Okay, next slide. This is another example. It's actually a blown up version of one of the drawings in the last picture, just to show you more how these drawings look. Next slide. This is a list of documents that were in the Terminal 117 design report, and there are drawings and specifications, a sort of a narrative summary, the design report, and many plans that focus on particular features like how to monitor the work as you do it, how to monitor the work after you do it and you're checking over the long term. How do you monitor water quality to protect water quality? What about the community health and safety? What is it going to cost? So these are lots of elements, and chances are that the remedial design for Lower Duwamish Waterway will include many of these elements, if not all. Next slide, please. This is the last slide. I know you're crushed. There is less pollution coming into the river now than there used to be, thanks to environmental laws. But during design, EPA will be coordinating with the Department of Ecology, which is the lead agency for pollution source control. We all want to make sure that ongoing pollution sources like stormwater, which can carry pollution from roofs, streets, paved areas, will not cause sediments to become contaminated again and require cleanup because it's above action levels. We also know that the contaminated sediment itself moves around in the waterway when the tide goes in and out, and when the river flows or boats erode the bottom. So for us, cleanup of the contaminated sediments as soon as we can is an important part of reducing pollution in the water and sediments of the Lower Duwamish Waterway. So next slide, please. If you have questions about that, let me know.
Thanks, Ellie. We had a question in the chat and answer in the chat, but I think it's worth repeating so that everyone can hear it. So Adrian's question from Adrian from the DRCC, how do we know if a cat becomes disturbed if it is underwater and we can't see it? And then James from DRCC suggested that we find out through testing every 5 years.
Thank you, James. And testing every 5 years is kind of a minimum time frame for us to do what we have to do. We have to report on whether the cleanup is protective still of human health and the environment. But it doesn't mean you can't do more often. And at the early action area cleanup, we have had monitoring in some cases every year or every other year. And over time, you might decrease the frequency of monitoring if you see that things are stable. But we don't have a final plan for the monitoring in the Lower Duwamish Waterway. That will be developed. To answer the specific question though, we can very accurately measure the thickness or the depth of water over the bottom. And so comparing the maps that we make of the bottom of the river depth, right, the bottom of the water, we can compare that from year to year and see, or a year to 2 years apart or 3 years apart, and see if some areas are losing material or some areas are gaining material. And we also will do chemical testing periodically. So we may not be looking at the sediment, but we can kind of see it chemically and physically. We don't expect to have caps in areas where there's, I have to remember, table 28, where there's high likelihood of erosion. So if we do cap, we can put coarse material like armoring on top of the sand, and that protects it. I rambled a little bit on my answer. Any other questions?
Let's see. James from DRCC, do you have a question?
I have several. And Ellie, I really appreciate what you're doing today. One of the things that you talked about was the sediments that were coming down from the Duwamish River, and that you already had a pretty good idea of what's going on. And I was kind of questioning that because the pollutant loading assessment and the modeling that's going on with that is still in process. So how do you feel that you have a good handle on that, or, you know, because I'm part of that technical committee and we're working on that. So I just was wondering about an answer on that.
I think the question that was asked is, do you know something that changes your understanding of the natural recovery time frame estimated in the ROD? And my answer was that I don't have information that says we should change it. The pollutant loading assessment will probably only create more likelihood of cleaner material coming downstream, because it will lead to pollution control efforts in upstream areas. But I don't think that what I said is in contradiction. I don't think we have 100% handle, but we did get, I think USGS got a bunch of new data after the ROD. And the assessment of that data says it's not a big enough change of actual data, right, to make a different decision. If the pollutant loading assessment changes that, we'll find out. But I think if it changes it, it will only mean that there's going to be cleaner material. I could be wrong, but that's my guess. So did I answer your question, James? I'm not quite sure I understand why.
You did, absolutely. And it brings up another question about data. When will data samples that we've most recently taken be available so that the public can, you know, take a look and understand them? When you're talking about being able to help you make decisions about cleanups, it's important for us to have that data. And so when will the more recent data be available?
So since the ROD, the Lower Duwamish Waterway Group has done two big things. And one is new site-wide data. They did that in 2017, 2018. And the data evaluation report for that can be found on EPA's website, or probably more easily on the Lower Duwamish Waterway Group website. It's called AOC3, just because that's the name of the agreement under which that work was done. They're now doing sampling, and they did sampling in 2020 in the upper reach to support remedial design. Those data are available on Lower Duwamish Waterway Group's webpage.
There was another set of data that you asked them to do, and you have not released that yet.
No, I don't think I've released it, but it has been released, and it is available on the Lower Duwamish Waterway Group webpage. But it is data files, and I think in about a month and a half or so, we're going to see the maps that explain things, and we're going to see summaries of averages and other statistics, and we'll see maybe even kind of preliminary outlines that need further data to refine them. So there's a lot more information coming, but if you want the chemical results, those are available.
And Mishu just put the link to that set of project files from the Lower Duwamish Waterway Group in the chat.
And my last question, both City of Seattle and King County Council and City of Seattle Council have actually said that they want to have the most modern dredging that's available, and which we would take it as being what was done at the Boeing Plant 2 site. And that is not spelled out in the ROD. How do we as a community push to make sure that the dredging that's being done in the Duwamish River is being done to the highest quality that it can be done?
That is, so when it comes to the design, they don't always specify equipment, but if they do, they can require contractors to use a particular kind of equipment. Sometimes they just say they have to meet a particular standard, like you can't cause turbidity in the water more than a certain number at a certain distance from the work area. So that question of how do we ensure that the contractors use the best equipment, I think that's, if it's not specified in the specifications, then it's a matter of ensuring that a responsible contractor is selected and that you review the requirements for that selection. You can also make your desire known to the city and county. Obviously, I don't want them to use something that will create a mess, and I really don't think they want to use something that will create a mess. So we just aren't there yet. We don't have specifications because we don't know where in the upper reach capping will be required. They may be thinking about this right now, but I don't have a draft report at this time. But that's why we have this roundtable, is for feedback.
Absolutely,
Okay.
and thank you so much.
James, we've got a question in the chat, so can I put a pause on your questions?
Please.
All right, we will get back to you. So
Yeah.
here's a question from the chat, and then I'd also like to check in on our language lines to see if there's any questions there. This is a question from Saporn in the chat. Saporn, sorry. When will the actual cleanup start? And what is the time frame to
សុភ
know
នគាត់ចង់សួរថា
which
តើការសម្អាត
remedy is decided?
Yeah, so at the stakeholder meeting recently, I put up a slideshow for the remedial design schedule. And Mishu, did you happen to have that, and can you share your screen to show it? We
She's
will,
taking a look.
we will do remedial action after the design. We anticipate the design will be final at the end of 2023. And there are some other planning requirements and limits on work in water. So we probably would, the soonest we could start would be late summer 2024. So this is the upper reach, that's the 2 miles of the south part of the waterway. And we are finishing the phase 1 sampling pre-design investigation. We will be starting additional monitoring plans this spring and do monitoring sampling this summer as well. So that's why it's important for me to get you guys up to speed on how to interpret the ROD so that you can weigh in if you have opinions on phase 2 sampling. Then in 2022, we can look at the preliminary, which is 30% remedial design. And that's a really big point along the way when people can get a sense of how much of what kind of cleanup is likely. And at each level of detail, 30, 60%, 90%, 100%, the picture gets filled in with more details. You might have the outline of the titles of plans in one, whereas the next one would have the sections and headings and maybe some descriptive information. And the next one would have an actual plan. And then after much comment, it would have a final plan. So it is a process of going into greater detail, and we expect that to take 2020, much of 2022 and all of 2023.
Okay, thank you, Mishu, for sharing that, and Ellie for responding to that question there. Let's do a check-in with our language lines. So checking in with the Spanish line first. Carla, any questions? No. Okay. Thanks, Carla. James, any questions?
My room is still negative.
Okay, thank you. Fung, any questions?
Not at the moment.
Okay.
Oh, sorry, there is actually one, but you can go ahead and come back to me.
Okay, we'll come back to you next. We had a question in the chat from Paco. Actually, I think maybe 2 questions, but let's start with the first half of it. So how do we how do we stop more PCBs and other contamination going into the river, Ellie?
I'm sorry, I got distracted. What is the question?
How do we stop more PCBs and other contamination going into the river?
That question has a lot to do with source control, and that isn't something that I'm in charge of, but the Department of Ecology is using its regulatory authority. They issue permits for facilities. They issue, they require monitoring of discharge. They are overseeing the King County and City of Seattle source control implementation plans for stormwater and sewer overflows and all kinds of things. So I think the answer is we keep doing it. It's a lot of work to control every bit of PCBs, but already I think we can say there have been improvements in PCB levels coming out of, coming from land into the water. One thing that's tricky with PCBs is that it is sometimes present in old building paints or caulking or roofing, maybe, I don't know, it's in building materials. And so sometimes it's hard to get every little bit of it. But in terms of major sources, I think that's, like if there's a spill like there was at Denver Avenue, all we can do is make sure we try to detect and stop that kind of problem.
Thanks, Ellie. And the second half of Paco's question, do you think that COVID-19 could get into the river and affect human health?
That is not my department, but I think there's a lot of water. I do know, I know people have raised concerns because there are stories in the news about scientists measuring COVID in sewage. And they use it as an indicator of COVID in the people to know whether there are a lot of people who have COVID-19. I think in the way that you can go outside and breathe fresh air, and if somebody walks past you who has COVID-19, your risk is low. I would say in the water, it might be very similar. But I am not an expert, so that is just my, if it were me, I probably wouldn't go into the Duwamish Waterway, especially after a big storm, because sometimes sewer water has to be combined with rainwater and overflow because it has overwhelmed the sewer treatment system, the sewage treatment system. So that's a problem that is being worked on right now.
Thank you, Ellie, for that question, or answer to Paco's question. And Paco, thank you for your question. Fung, let's check in with you and the folks on your line.
Fung, you're on mute.
I think she's getting her input.
Okay, I'm unmute now. Okay, so Duik has a question. She wants to know what year was the cleanup, and did it take, if it takes 7 years to finish the cleanup, then what happened after that? So that's the first question, set of questions. The second part of the question was maintenance of the Lower Duwamish River after the 7 years cleanup. Any plans for that, and how do you do it to maintain the quality of the river?
Right. Let's see if I can remember. I lost track at the beginning. The question was, how do you? Sorry, I did the first part.
Yes. So, what year was the cleanup when it started, and how long does it take for the river to return to normal? And what happened after that? Will there be any plans for maintenance, and how?
Okay. Yes. So the record of decision says that after cleanup, after active cleanup, which it estimated would take 7 years of construction, after that, we expect that over 10 years, the sediment would get better everywhere, not just where we did cleanup, but where we didn't do cleanup. So overall, the cleanup levels would be, if not met, we would see continued reduction in pollution in the sediments. And we would monitor that at least for 10 years, because that's as long as we expect it to take, but we would continue to monitor it to verify if we need to. So long term, how do we maintain the river? Well, we have a long-term monitoring and maintenance plan as a requirement of the design. When the upper reach design is done, there will be a draft of that plan. But because it deals with the whole waterway, the plan will have to evolve and change to include each part of the waterway as cleanup continues. And that plan will talk about how to maintain areas that are capped and how to monitor to ensure that the cleanup levels are being met continuously. And then pollution sources, you know, the Department of Ecology will not stop its work protecting water quality. That is their job. So I think that we just keep going and make sure that we are checking, and if there's a problem, we have to respond to understand why.
Great, Ellie, thank you for that.
Thank you.
Thanks, and thank you for the folks on the line who shared that question. James from DRCC, did you have another question?
I'm just going to close and get an overall view from Ellie. When we look at the target and the goals of the ROD, protecting human health, I think you and I both talked about this, is that we will probably fall short in protecting human health, but we might get closer. How do you see us working to get the best cleanup that we can through this process? In other words, you can only do what the law says, and the community might look at that as saying, maybe we could do a little bit more, or that type of thing. What would your advice be to the community?
Well, it's a long process. So my advice to the community is keep asking questions. Ask them of me, but ask them of the parties who are doing the work. You're doing what you need to do. So being involved in the roundtable is where you can keep up to speed on every development during remedial design, and you can weigh in on the design. In terms of making it the best cleanup ever, I want it to be the best cleanup according to the ROD ever. But if you want something that goes beyond the ROD, I think that is something that you know best how to do.
Thank you, Ellie.
Okay.
You're on mute.
I did.
Thank you. I thank you, Ellie, for responding to that question. Thank you, James, for that question. And thank you, everyone, for being here and being part of this webinar, for your thoughtful questions and for your engagement in the cleanup. there is, we do a tech and language debrief at the end. So you're welcome to stay for that, particularly if you have any suggestions for improving the structure of the online meetings. But otherwise, I just want to say thank you. This recording will be available on the website at some point soon. And the slides are already up there, so you can go and refresh your memory at any point that you want.
Rachel,
Ellie, do you want to say anything to close? Is there anything I missed?
I did have one thing. There's also a question, a reminder question. Yeah, I did want to say that before you forget everything that you learned today, I recommend that you go to the ROD, the Record of Decision, and you find Table 28, and you go to the figures 19, 20, figure 19 and figure 20, the flowchart figures, and you go to Chapter 8, cleanup level. And just remember what those are the parts that I have put tabs in my hard copy. Looking at it right away, what I think you'll find is that it actually fits together and makes sense. And the sooner you do it, the more comfortable you'll be. I also want to thank again the Roundtable Steering Committee, the interpreters, Triangle, and my own EPA community involvement team. Thank you, Kay. Thank you, Tanisha. Thank you, Julie. And call me if you have questions. I always am happy to answer them. Fong, you asked what year was the cleanup started? Do you mean the study or actual cleanup?
The actual cleanup, and you can include the other part too.
Okay. The study started, so this became a Superfund site in the year 2001. And the study started right away and took about 14 years to get to a cleanup decision. It was a long process and a lot of work was done by the Lower Duwamish Waterway group. The cleanup of the early action areas, some of them were in, there was some in the 1990s and some were in the early 2000s. And then most of them were in the window of kind of 2010 to 2015. So does that answer your question, Fong?
Yes, thank you.
Okay.
Great.